All right, we're going to take a look at factoring the greatest common factor and factor by grouping. Okay? Factor by grouping is actually going to kind of go along with the greatest common factor. So let's look briefly at a common factor. Okay? So let's say I have 3x minus 15. Right? And I'm wanting to factor out the common factor here. And of course, I want the greatest common factor, the largest value that will go into both 3x and 15. Well, that'll be 3. I can factor a 3 out, and that leaves me x minus 5. Right? When I'm factoring, it's really division. 3x divided by 3 leaves x. 15 divided by 3 leaves 5. Well, let's say we had 12x squared minus 8. Well, let's see, between 12 and 8, the greatest common factor would be 4. So if I factor out a 4, let's see, 12 divided by 4 would be 3x squared minus 8 divided by 4 is 2. Right, so when we're talking about a greatest common factor, we're always looking for a number first, okay, which of these two I had a value in common, a number. Sometimes we have both a number and a variable in common, so something like this. Let's go 4x squared plus 6x. Okay. So when I have numbers and variables in common, I just look at them individually. Hey, what's in common between a 4 and a 6? 2. Well, they both have x's, so how many x's could I factor out? I can factor out 1. So when it comes to the variable, it's always going to be the smallest power, and basically this is why I can't take x squared out of this guy. I can't take 2 of them out because there's only 1 sitting there. So the most I could take out would be 1. Up here, I see x squared, I see x. But again, there was nothing with the 15 or the 8, so I could not take a variable out. If I take out a 2x, 4x squared divided by 2x leaves me 2x. 6x divided by 2x plus 3. That's what I would be left over with. Okay. We can always go back and mentally go through the multiplication to make sure I factor correctly. Here we'd have 4x squared plus 6x. Here, 12x squared minus 8. Well, let's say we have, not 5, it'd be number 4. Let's say we have 12x squared minus 12x. Well, what's in common between 12 and 12? Well, 12 is. And there I'm seeing an x in common. Take that smallest power. So if I take a 12x out, that will leave me an x, because 12x squared divided by 12x will just be x. And then 12x divided by 12x, 1. That 1 is one of the things that's forgotten a lot of times. Remember, it's division. 12x divided by 12x is 1. Also, think about multiplying it back through. 12x squared minus 12x. That's really the basics of looking for a common factor. Now let's look at a couple other looks that maybe get a little bit more difficult look, but we're not going to change our process. So let's go with 3x squared y cubed plus 9x cubed y squared minus 12 x to the 4th y. Okay. So I've got 3 things going on here. I've got a value, got the coefficients, I've got an x and a y, all of which have something in common. So I look at the numbers first. I see a 3, a 9, and a 12. So what's in common there? Well, I've got a 3 in common. 3 goes into both all 3, 3, 9, and 12. I look at my x's. All right, I got an x squared, x cubed, x to the 4th. They all have x's, so I'm going to have x's in common. I can factor out an x squared. Okay. And I can take out an x squared That's going to be that smallest power. I can't take any more than 2 out of this one, and I've got more than that there. The y's. I see a y in every one of them, so I know there's a y in common. Now it's how many can we factor out? Well, I can take out just one. I got 3 here, 2 here, 1 here. So the most I could take out would be 1. Again, that lowest power. When I factor that out. Let's see, if I take 3x squared y from 3x squared y cubed. 3 divided by 3, that's gone. X squared, that's gone. I've got y cubed divided by y. That would leave me y squared. 9x cubed y squared. 9 divided by 3 is 3. X cubed, taking x squared out would leave me an x. And y squared, if I take a y out, would leave me a y. Minus, let's see, 12. Take 3 out would leave me 4. X squared, it's going to leave me x squared there. And no y's left. Took that y out. Now what we want to remember is it's division. Okay. So sure, this right here, looks much simpler than this. Okay, a lot more going on. When I'm factoring that out, that term, that greatest common factor, we want to remember this is what's really happening. I got 3x squared y cubed divided by 3x squared y, 9x cubed y squared divided by 3x squared y, and minus the 12x to the fourth y divided by 3x squared y. That's what's really happening. So I can see the 3's are canceling here. X squared is going there, leaving me a y squared. 3 goes into 9 3 times. It's going to leave me an x up top and a y up top. There's that 3xy. 3 into 12, 4. It's going to leave me 2 x's, and y is gone. There's that 4x squared. That's what's really happening. Now, visually, we're wanting to just kind of divide this out. We can check back with multiplication. That is what's happening here on this guy when I'm taking a 3 out. Divide each one by 3. That's what's being factored out. This just definitely looks much more simplified than this one is. A lot more going on here. Another look, the common factor. Remember, we're looking for anything in the terms that would be in common. So, let's say we had x plus 3 minus 2, x plus 3. Looks a little way different than what we kind of saw over here, but I can still see something in common. I see an x plus 3 sitting in common. Each one of these terms has an x plus 3 in common. So I'm going to factor out that x plus 3. And when I do, that leaves me an x in the first term and a minus 2 in the second term. Let's look at another one kind of like that. Let's say we had y minus 4 plus 7, y minus 4. And that doesn't matter what variable I'm using. I can look at that and see, hey, I've got a y minus 4 here, and I've got another y minus 4 right here. So that's what's in common. I'll take out that y minus 4, and that's going to leave me a y plus 7. Again, if I take y minus 4 out of this first term, leaves me just a y. If I take y minus 4 out of the second term, leaves me just a plus 7 there. That's what's happening. Right? Now, let's take a look at grouping. Right? When we're doing a grouping method, what we're going to end up with is something similar to these two right here, where we're going to see a binomial that ends up in two different parts. Okay? So we're going to take our greatest common factor idea, we're going to apply it to the grouping method of factoring. When I am factoring by grouping, take that out. When I'm factoring by grouping, what's leading me to this is I see 4 terms. That's what's leading me to thinking of factoring by grouping. So I'll see something kind of like this. Let's say 21x cubed plus 28x squared plus 9x plus 12. All right, when I look at that, I've got 1, 2, 3, 4 terms. I look across. I'm looking for something in common. Well, I don't see anything in common between all 4. I do see some common things between a few of them. Let's see, 3 are going to 21, 9, and 12. I got x's here. I see some things in common, but nothing in common between all 4. This is when I want to look at a grouping method. So a grouping method. What I'm going to do is group the first 2 together and the last 2 together. First 2 and last 2. The purpose of this is to kind of reduce it down because now instead of 4 terms, I now have 2 terms. Here's one of them. Here's the other one. I have 2 terms now. Parentheses, group those, separated one whole term. There's the second whole term. Now I can look at these terms individually. Well, I see a 7x squared in common here. So there's back to that greatest common factor there between those 2 terms. That will leave me a 3x plus 4. I look at the second term, the right side. I see a 3 in common, and that leaves me a 3x plus 4. When I grouped them, taking out a common, look what's showing up there. I now have a common factor of 3x plus 4. So that 3x plus 4 is coming out, factoring out of each one of these terms. Again, first term, second term. I can see those same things. Okay? And that will leave me with a 7x squared plus 3. And there's my factored piece. Let's look at this. How about 35x cubed minus 25x squared plus 7x minus 5. So once again, I do see some kind of common things, but definitely nothing in common between all 4 terms. That's okay, but I do see 4 terms. So that's going to tell me, hey, let me try grouping the first 2 and the last 2. First 2 and the last 2. In that first pairing, I see common factor of 5x squared. There's that greatest common factor there. That will leave me then 7x minus 5. I look over at the second term, and I don't have anything in common. I'm just left with that 7x minus 5, which is fine. But now I'm seeing, wait a minute, first term, second term, wait, there's a 7x minus 5 in common there. So then what's left over? Well, I'd have a 5x squared here plus 1. Because remember, when we're taking out those common, it's division. So 7x minus 5, factored out, that would be 7x minus 5 divided by 7x minus 5 is 1. So there's where that 1's coming back in. Let's look at one just a little bit different here. Let's go with 7x cubed plus 4x squared minus 56x minus 32. Okay. One primary difference here in number 3 versus the first 2. Yeah, I see 4 terms. I don't see something in common between all 4, and that's okay. So my first thought is I want to split them up, group the first 2, group the second 2. But look at where my split is. Right? Where I'm wanting to split these 2 up, right here, there's a negative sitting there. Okay? Where that negative is sitting, I want a plus. Now look right here in the middle. Number 2 had a plus. Number 1 had a plus. Okay. So I'd like to have a plus between the 2. So when I split it, I'm going to write it like this. 7x cubed plus 4x squared plus negative 56x minus 32. So I can carry that negative in with the 56. I just want a plus in the middle. We'll talk about a little bit more why I want that plus, but let's finish this thing out. First pairing, I can take out an x squared. That'll leave me 7x plus 4. That second pairing, 56 and 32. 8 is in common between 56 and 32. So I'm going to factor an 8 out, but this time I'm going to factor out a negative 8 because we don't leave with a negative. So I'm going to factor out that negative 8. When I do that, that's going to leave me 7x plus 4. There's where I'm seeing. Looks pretty similar to what we had in the first two here. In that problem, I've got a 7x plus 4 in common. Take that out. And I'm left with an x squared minus 8. Now let's talk about that plus in the middle real quick. Okay. Technically, I don't have to have a plus in the middle. Okay. But let's kind of look at what happens if I put a minus in the middle here. And this becomes important. If I had 7x cubed plus 4x squared, and I left a minus in the middle, then that means this would have to become 56x plus 32. It would have to change this sign to a plus. Again, think about multiplying. Negative, negative would get me back to this. Okay? I see this missed more often than anything, forgetting to actually change that sign over there. Students forget to change the sign over there. So one of the things that I like to suggest is, instead of putting the minus and changing that sign, if you put a plus, okay, and then you go to factor something out, look at that negative right there. That's going to remind me to pull a negative out with it. And when I do that, then I'll remember to change those signs when that negative comes out. So it kind of helps me out as far as meeting that pattern and taking care of that negative. Okay? We want to make sure that we take care of that negative, and we have to remember when that negative comes out in front of the parentheses, it's going to change the signs. Right? And that's where we run into a little bit of problems sometimes. The nice thing is, once that's done, look what's showing up. There they are. There's that 7x plus 4. Now the greatest common factor in the two terms, just like the 7x minus 5 was here, and just like the 3x plus 4 was on that part.